So I'm looking at question, the first one, number 3. There's two number 3s here. However, basically we're given this function. Actually, it looks like you calculated this function. So they told you that the future value at the end of n years is going to be the e to the power of 0.05 n times p. So this is the principal, which is really just like the initial value. So the initial value in a case like this would be how much money did you invest initially? So that's what P is. And then N, the variable N, is like the number of years that have passed. So if you know how much money you invested and you know how many years it's been, you could figure out how much money you have now, or how much your investment is going to be worth. So it says, in how many years will the future value double? So what we're going to do is pick an arbitrary value. So I'm just going to pick like $100 for our principal amount. And that means we want to find out how long does it take till this value, the final value, would be worth $200. So these are made up numbers. But the thing is, you can pick any initial investment amount. You could have picked $1,000, you could have picked $1, you could have picked $26.50. It doesn't matter, as long as the final value has doubled, right? Because that's what they're asking us about. And you'll see why the initial amount is arbitrary in just a minute. So basically what we're going to do is we're going to plug in these two things into this equation over here. So S of n, in other words, the future value, 200, is equal to e to the 0.05 n times our principal amount of $100. Now, the first thing that we're going to do to solve this equation is divide both sides by 100. So if you notice right here, we're doing 200 divided by 100. If we had picked any other principal amount other than $100, this part over here is always going to work out to be 2, right? Because the amount that you have now divided by the amount that you started with is always going to be 2 in the situation where the future value is doubling. Anyways, on the right we're left with e to the 0.05 times n. So going back to algebra 2, if your variable is in the exponent, what you need to do is log both sides. So what we're going to do is take the natural log of this, and we're going to take the natural log of this. Now, natural log of 2 is some weird decimal, so I'm actually just going to leave it as natural log of 2 for now. Now, on the right-hand side, the reason that we were actually doing the log is that the log cancels out this e, so what we're left with is 0.05 n. And then to find out what n is, you just divide by 0.05. So we got ln of 2 divided by 0.05. And you type that into your calculator. And you should get 13.86. So n equals 13.86. Now don't forget, this is actually a time, so this is 13.86 years is how long it would take to double your money with the given scenario. Oh, I'm now noticing that it's asking to round your answer to 1 decimal place, so I would just call this 13.9 years. And that's going to be it for this one. Okay, the next one, also labeled number 3. A firm knows its marginal cost for a product is MC equals 2x plus 30. The marginal revenue is also known, and it is 48 minus 4x. And the cost of production of 100 units, in other words, cost to produce 100 units, is $13,120. Find the optimal level of production. So I suspect that this is going to be, what is this going to be? This is going to involve some antiderivatives, some integrals. Hopefully you've learned those. I haven't talked to you in a few weeks, so it's possible that you have. So find the optimal level of production. So, okay, marginal cost is actually the derivative of the cost function, and marginal revenue is like the derivative of the revenue function. So we're kind of going to work backwards. And since we know something already about the cost function, I think we're going to work with that one first. Okay, so I had to pause the video for a couple of minutes and just think about this. So we know something about the cost function, and that's basically an initial value, right? If we produce 100 units, we know what the cost of that is going to be. And we actually know something about the revenue function as well. And I had to read between the lines here. They didn't actually say this outright, but I think this is reasonable. And that would be the revenue, if you produce 0 units, should be $0, right? If you don't sell anything, your revenue is going to be $0. So I think that's going to be the initial starting point for that function. Okay, so we're going to go down here and we're going to figure out if the derivative is 2x plus 30, then what was the original cost function? We're going to try and figure out what that is. Now, hopefully you can kind of see where this came from. Basically, I'm just going to be integrating 2x plus 30 because we have the derivative. So if we integrate, well, I can write this out. If we integrate the derivative, like this, so the integral of the derivative is equal to the original function. So we're going to try and work backwards using an antiderivative. 2x plus 30. How do we integrate this? Well, it's going to be x squared plus 30x plus potentially some constant value. I'll actually use k, so we're already using c, so that might get confusing. Anyways, so now we know that the original cost function, whose derivative was 2x plus 30, must be x squared plus 30x plus k. And then we know something about the initial value, right? We know basically when x is 100 units, then the cost is $13,120. 120. So we're going to plug in those values, and we're going to try and find out what was the constant at the end of this equation. So the cost for the quantity that we know is 13,120, and that's going to be this. So we know everything except for K. So it's like 10,000 plus 3,000 plus K equals 13,120. So all of this makes 13,000, so I think that means K has to be 120. So now that we know what our constant is, we can say this function is x squared plus 30x plus 120. So now we have a function for cost, meaning we could plug in any number of units and find out how much it costs to produce that number of units. So I'm actually just going to save this. Erase everything else. But I'm going to save this function because we're going to need it in a minute. Okay. So we're going to do the same thing with the revenue function. Right? We have its derivative. And this is one of the fundamental theorems of calculus, is that if you want the original function back, you can just integrate the derivative. So we're going to go ahead and do that. We're going to take the integral of 48 minus 4x. And that's going to be 48x minus 2x squared. Again, plus some constant. And then we're going to use the initial value for revenue, which is if you produce 0 units, or if you sell 0 units, then your revenue is going to be $0. So if we plug in 0, 0 plus k is equal to 0, we find out that k for this one is just 0. So now our revenue function is just 48x minus 2x squared. Okay, now we have our revenue function and our cost function, and now we have to remember that basically microeconomics or something, if you want to calculate your profit, it's really just your revenue, right, how much money did you make, minus how much money did you spend, so it's your revenue minus your cost. So we're literally going to do our revenue function minus our cost function. We're going to find out this is equal to, let's see, negative 3x squared, right? Negative 2x squared minus another x squared. Now we have 48x minus 30x, so that's going to be positive 18x, and then we have subtracting 120. So this is going to be our profit function right here. So this is actually the answer for part B. Find the profit function. We're now going to go back and find the optimal level of production. So I did part B first for a reason. I'm just going to erase a few things here. I'm going to keep our 3 functions that we need. And I'm going to eliminate everything else. Okay, so I believe we might not even need cost and revenue, because I think the optimal level of production. So I'm going to quickly sketch you a graph of our, actually, I don't know exactly what this looks like, but the profit function has a y-intercept of negative 120. It's upside down. So it's probably going to look something like this, which means we need to find this value, right? I'm assuming that the optimal level of production would be the level at which our profit is maximized. since we're a company, right? The optimal level would be where are we making the most amount of money. So what we're going to do for that is take our profit function and we're going to take its derivative and set it equal to 0. Why? Because right here at the maximum profit level, P max, the slope of the tangent line is 0. In other words, the value of the derivative at that point is 0. So we're going to find out what is our derivative of profit, or P prime, and that's negative 6x plus 18. And we're going to find out when is this equal to 0. Subtract 18 from both sides, divide by negative 6. It looks like x equals 3 is the answer. So that means this point right here, 3, is where the maximum profit is going to happen. So it looks like that's going to be the answer for part A, is that if we produce 3 units, that's the optimal level of production. That's not very many units. I'm wondering why that is. Okay, so to find out what the actual profit when we produce 3 units would be, we're going to plug 3 back into the profit function. So negative 3 3 squared plus 18 times 3 minus 120. We'll go back to our calculator. So I'm getting a negative number here. We got negative 93 is the profit. That's not good news. That means this firm is about to go down, right? The maximum profit is a negative number. That's not a good thing. Okay, so part C is going to be there's a loss of $93. I think that's the answer. Okay, so next question is number 4. It's similar to the previous one, where we know something about the cost, something about the revenue. We need to find the profit. Okay, so the marginal revenue, which is actually the derivative of the revenue function, is 1200. We know the marginal cost, which is the derivative of the cost function, is the 30 times square root of x plus 4. And we know we have a fixed cost of $600, which basically means even if we produce 0 units, the cost function is still going to work out to be $600. So if they tell you an initial value like this, basically this is going to be the constant. If this one is 0, then you know the other one is the constant. But I'll show you how that works out anyways. Okay, so what we're going to do is just like what we did before. So to get back to the original revenue function, we're going to integrate the derivative. Right, integral of the derivative is back to the original function. So we're going to integrate just 1200. And that is 1200x plus something. And because this is a revenue function, if we produce or if we sell 0 units, then our revenue should be 0, which means our constant is going to be 0. So our revenue function is 1200x. It's pretty safe to assume that the constant for revenue functions is always going to be 0, unless for some reason you're still making money even if you sell 0 units. But usually that's not the case, so it's a pretty safe assumption. Anyways, here's our revenue function. Now we're going to do the same thing for cost. Again, fundamental theorem of calculus. So if we integrate the derivative, we should be able to find our original function. So we're going to integrate 30 times square root x plus 4, which actually easier said than done, right? This one's a little tricky to do. First thing I would do is bring this constant of 30 to the outside of the integral. And I'm also going to rewrite square root of x plus 4 as x plus 4 to the 1/2. So since this is essentially a chain rule, to integrate this, we're going to have to do a u substitution. So we're going to let u equal to the inside, so x plus 4. That means du is just going to be dx, which is good news. It's going to make our life a little easier. Okay, so then we're going to rewrite this integral once again. U is x plus 4, so this is actually just u to the 1/2, and dx is equal to du, so that's times du. Now the integral of this is going to be 30 times u to the 3/2, actually times a 2/3, because we have to divide by 3/2, and then plus some constant. And well, I think we already know the constant. I don't know, we'll see. Okay, so this is going to be our cost function, and then we just plug u back in. So this is going to be 30 times 2/3 times u to the 3/2, so x plus 4 to the 3/2 plus some constant. 2/3 of 30 is 20, so we can evaluate that now. We've got 20 x plus 4 3/2 plus k. And then we're going to go back to our initial value up here in the top right, is that if we produce 0 units, the cost is still going to be $600. So we're going to plug in 0 for x, and set y to 600, or cost to 600. So 0 plus 4 is 4. 4 to the 3/2 is 8. You can plug that into a calculator, but square root of 4 is 2, and then 2 to the 3rd is 8. Okay, I'm going to go over here. So we've got 20 times 8 plus k is equal to 600. 20 times 8 is 160 plus k equals 600. That means k is going to be 440. And then we're going to go back to our cost function, get rid of k, and plug in 440 instead. So plus 440. Okay, so actually I was wrong about the constant in that case. Happens to be 440. Okay, so we have our revenue function. We have our cost function. I think we could actually now find our profit function. And yes, that is what we'll need to do. It actually says find the profit or loss from the production of 5 units. So we're going to find our profit function, and then we're going to plug in 5 into that function. So I'm going to erase some of the stuff here we don't need anymore. Okay. So once again, our profit is just our revenue minus our cost. So we got our revenue 1200x minus our cost 20 x plus 4 3/2 plus 440. If we want to get rid of the parentheses, we could call this negative 20 x plus 4 to the 3/2 plus 1200x and then minus 440. Okay, so this is going to be our profit function. And then they're basically saying find the profit or loss when x is equal to 5, right? When we're producing and selling 5 units. So we're going to find P at 5 units. Negative 29 3/2 plus 1200 times, why did I put 3? That should be a 5, minus 440. Okay, 9 to the 3/2. Again, square root of 9 is 3. 3 to the third is 27. So this is going to be negative 20, 27. 12 times 5 is 60. And then we put the 2 zeros back. Minus 440. Okay, I'm going to plug this into a calculator now. And I got 5,020. Okay, so this time it's positive, which means this company is actually doing something right. That's pretty good. So that's going to be the answer for part A. Production and sale of 5 units is going to result in a profit of $5,020. Part B, how many units would result in the maximum profit? Okay, so let's work on that. I'm going to keep the profit function and erase everything else. Okay, so just like last time, wherever the profit is a maximum, the optimum level, that's going to be wherever the derivative is equal to 0. Now I don't exactly know what this profit curve looks like because I don't know what a 3/2 power is going to be, but you know, I don't know. Maybe it's something like this, and if it has a curve, then the maximum is always going to be where the slope of the tangent line is equal to 0, and that's always where the derivative is equal to 0. So we don't have to know what the curve looks like to know that we need to take the derivative and set it equal to 0. Okay, so the derivative of this piece is going to be 3/2 times negative 20 times x plus 4 to the 1/2 plus 1200. This piece goes to 0. Okay, so this is going to be negative 30 times x plus 4 to the 1/2 plus 1200. And we need to figure out where is this equal to 0. So we subtract 1200. Divide by negative 30. Which is 40. Hopefully. Cross out the zeros. Yeah, it's 40. Is equal to x plus 4 to the 1/2. That's actually square root x plus 4. So then we square both sides. 1600 equals x plus 4. That means x equals 1596. So So 1,596 units would be the point at which you're going to have a maximum profit. And that's going to be the answer for part B. Hopefully this video was helpful. Let me know if you have any further questions. Thanks.